Okay, everyone, we're going to move on now to the next lesson, which is called Lines and Transversals. Now, I want to be very clear that this lesson is more about terminology and identifying pairs of angles. What this lesson is not is using these terms to do not calculations, but more missing finding angles. Like in the next lesson, after this video, we're going to use the terminology we learn here to solve for missing angles. So I want to be very clear. This lesson is not about finding missing angles. This lesson is about understanding the terminology. Once we have the terminology in place, we can use that knowledge, information, to allow us to find missing angles, and that will be in the next video. Now, what I'm going to do here, first of all, if you look at your notes package, as you look down right now, you can see vertically opposite, interior, alternate angles, so on and so forth. That's on page 25. And of course, also, if you skip over to page 26, they're on there as well. So what I'm going to do is I'm not going to scroll through this like on the screen here. I'm going to leave it right here on this diagram, and I'm going to try to explain the different categories by simply looking here. So first of all, if you read up here, it says many angles can be formed by two lines and a transversal. So what the heck is a transversal is what you should be saying. A transversal is just a line that intersects or crosses two or more other lines. So if you look, here is your transversal right here in red. It's simply just a line that is crossing two others. It's just running right through them both. Now, when that happens, we get a whole bunch of special relationships or types of angles formed. And basically what I'm saying to you here is you're going to find very quickly that if you look at all these numbers, you have angle 1, angle 2, angle 3, angle 4. Well, the fact is, because we have two lines and a transversal, there's going to be relationships between these numbers. So let me get rid of that little bit of red drawing there, and let's move on. The first kind that we have here is vertically opposite angles. These are angles that are created by intersecting lines. These angles are opposite of each other. This is the easiest one. So when you have vertically opposite, one way I always think vertically is up and down, okay? But the point is, if you look here, so angle 1 and 3, you see they are on exact opposite sides of an intersection. By that definition then, 2 and 4 must also be vertically opposite angles. They simply are on different sides of an intersection. The same could be said down here. If we have angle 6, angle 8, angle 6 and 8 must be vertically opposite. They're on different sides of the intersection. And then, of course, the same could be said for angle 5 and angle 7. So vertically opposite is when you have two different angles on the exact opposite sides of the intersection. Now again, I'm just reading off the notes. I'm not moving down on the page here. What we have now are interior alternate angles. You're like, what the heck is that? So the way I think of this is, okay, here are our two lines. We have line 1 and line 2. And here's how I think of it. You see, we kind of have a space here between, think of this as, well, we're inside. We are in between lines 1 and 2. We are inside. Another word for inside is interior. If we were on this side of line 1 or on this side of line 2, those would be we'd be exterior. We are on the exterior or the outside of those two lines. So when they say interior alternate angles, you must think that you are in between the two lines. They must be between the two lines, okay? Because you want to be inside the two lines. The other key word there is alternate. So basically they're on kind of the other side of the transversal. So here's what I mean. If you look at 3, okay, so 3 is on the inside of the two lines or on the interior, but the alternate to that, or the opposite, would be 5. You see how they're both on the inside or interior of the two lines, but they are on alternate sides of the transversal. By default then, if we look at, let's look at 4. 4 is on the interior of line 1 and line 2. And now I want to find another angle that's interior. So that could be 6 or 5, but which one is it? If we're looking at interior alternate angles, it must be on the alternate side of the transversal, number 6. Okay, so what again? If you have interior alternate angles, you're looking for angles that are inside of the two lines and they are on opposite sides of the transversal. There is a little bit of a trick, but you can read that for yourself there under interior alternate angles. Next, we're going to move on there towards the bottom of page 25. You can see that you have corresponding angles. Now, corresponding angles, it says right there, are two angles that occupy the same relative position at two different intersections. Well, what the heck does that mean? Let's try to learn that based on, let's look at the example. It says there 1 and 5, angle 1 and 5. Well, hey, you guys all know what an intersection is. This is an intersection right here. We have a line and a line. Well, that's another intersection right there. So if we're looking for corresponding angles, we're looking for angles that occupy the same position at both intersections. So if you look here, angle 1 is occupying the same angle position as angle 5. Those are corresponding angles. You could carry that through to say, well, angle 2 would just be like angle 6, angle 3 would be like angle 7, and angle 4 would be like angle 8. So there you go. That's a pretty easy one. Corresponding angles are when you have angles at two different intersections that kind of hold the same relative position. Okay, we're almost there. I'm flipping over to the next page, but I hope you keep looking here at the diagram. So what we have now is exterior alternate angles. And you're like, oh my goodness. But you know what? It shouldn't be that bad, because remember, we have line 1 and line 2. The space in between, we called that the interior. Well, what do you call it if you're on the outside of those two lines? Well, that's the exterior. Okay? Exterior. Sorry, my pen's a little sloppy there. I should try to write a little bit neater. So what we have here are exterior alternate angles. Okay, so all that means is you have to be on the exterior of the two lines. Okay, so right now the only ones that count, we have 1, 2, 7, and 8. Those are the only exterior angles, but it does say here exterior alternate angles. So that must mean they have to be exterior, but on the opposite side of the transversal. Therefore, angle 1, we go to the outside down here, or the exterior, it must be angle 7. Those will be exterior alternate angles because they're both exterior to the two lines and they're on opposite sides of the transversal. By definition then, we also have another situation here of exterior alternate angles. Angle 2 is exterior to the two lines, is on the outside. If you come down and you look at 8, it also is exterior of the two lines and is on the alternate side of the transversal. Pretty easy, nothing there too much to worry about. Next, we're going to look at interior angles on the same side of the transversal. Now that one, you're like, oh my goodness. Well, it's exactly what it says. Interior angle, so we learned what interior is. So from here to here would be the interior. And what it simply says is interior angles on the same side of the transversal. Well, let's see. Here are my interior angles. If I look at number 3, we're looking for an interior angle on the same side of the transversal, so it must be 6. Another situation arises when we look at 4 and 5, because they both fit the definition of interior, and they're also on the same side of the transversal. Okay, one last situation here, and then we can move on, and that is going to be exterior angles on the same side of the transversal. Okay, very easy. We have by now gone over a million times. This has got to be the external to the two lines, and by definition, external, by definition, we know it says here exterior angles on the same side of the transversal. So that'd be like number 1 and 8, because they're both exterior and they're on the same side of the transversal. This also would apply for 2 and for 7. Okay, everyone, I know that's just some definition there, but believe me, this is going to help you moving forward. Please re-watch this video a few times as you need, and I will give you some practice. This is not difficult stuff, it's terminology, but you have to be aware of it. Good luck, everybody.